we're back and we're looking at ordered selections with identical elements. So this is where you have a whole bunch of stuff. For example, letters in the word Tasmania, Tasmania. In this section, some of those things are repeated. So in Tasmania, the letter A is repeated like 3 times. I don't know if I could spell. So this is problems involving permutations. So we're picking something out of a whole bunch, and restrictions with or without repeated objects. So what we've been doing so far is without repeated objects. Now we're doing with repeated objects. Let's have a look first. We come to actually counting the number of identical elements that we have. So for example, if we have the word presses and we were trying to figure out the ways that we could form words out of all of these letters, 1, 2, 3, 4, 5, 6, 7, then that would be 7 factorial, which is the same as 7 pick 7, 7p7. 7 factorial. So that ends up with a huge thing. But don't forget, if we have a word starting with one of these S's and another word starting with another of these S's, they're the same word. So we've kind of overcounted. We've kind of had too many words because we didn't realize when we were using 7 factorial that a lot of these answers were going to come out the same. So to get rid of the ones that are repeated, we just do a fraction and we do those on the bottom of the fraction, because when you're with all of this, to get rid of things, we don't subtract, we divide. And dividing is putting on the bottom of the fraction. So these E's, there's 2 of them. So we divide by 2 factorial because there was 2 factorial ways of like rearranging those E's that we would have like counted each way. And the S's, there's 3 of them. So we divide by 3 factorial to get rid of those double ups. So if we have a look, and this is just a generalized formula for that. So if we have a look at this example, 3 identical wine glasses and 5 identical tumblers can be arranged in a row. This is making me thirsty. Can be arranged in a row across the front of a cupboard. Count how many ways this can be done. Okay, so normally we've got 8 glasses. If we were not even considering that they were the same glasses, wine glasses or tumblers, if we just had our normal glasses, we would have had 8 factorial. So let me just change the background to have lines. I like lines. So for A, we would have just said 8 factorial. But that includes all the wine glasses as being different glasses and all the tumblers being different tumblers, but they're not. So I'm counting the different ways of rearranging the wine glasses in there, and I really don't, I don't care which wine glass it was as long as there's a wine glass. So I need to get, there was 3 wine glasses and the 5 tumblers, same deal. I don't want to count every single way I could rearrange those tumblers. I just know that they're tumblers. So whatever that answer comes out as, you need a calculator. I've got the textbook next to me, luckily, 56. Okay. If we now have a look at B, one of the wine glasses is chipped. So now we have 1 chipped, 2 wine. So we've got 1 chipped wine, 2 normal wine, 2 tumblers are broken and replaced by 2 different ones, 2 different tumblers, and then 3 of the original tumblers. Okay, so again, we would have wanted to start with 8 glasses, so 8 factorial. We have to get rid of all these rearrangements. So there's 1 factorial way of rearranging that chipped wine glass, 2 factorial ways of rearranging the other wine glasses, 2 factorial ways of rearranging the different tumblers, the new tumblers, and 3 factorial ways of rearranging the original tumblers. Calculator, that all comes out to 1,680. Okay. Now if we come to something with only 2 different letters, and you could actually think of this fairly similarly to like men and women or red light, green light, things like things like that. So Now I've got to read the question. Sorry, I'm a bit tired. So back when we were doing, why do we care about words only 2 letters? I don't. Okay, let's have a look at the next example. I don't know how this is different when we've been doing. Because we can. Okay, sorry, this just tweaked. We can actually do these exactly the same as these. It's just a different way of looking at it. So in these kinds of ones, you've either got wine glasses or whiskey tumblers. So this is just like a really specialized equation. When you know the number of wine glasses, you don't know the number of whiskey glasses, but you know it's the same as the whole lot minus the number of wine glasses. Like, this is just a specialized formula for these different cases when there's only 2 things. So to figure out the number of one thing, you do the whole lot minus the number of the other thing. So we've got 6 women, O-M-E-N, 4 men, yeah? Which gives us 10 total. So here, N equals 10 and R equals 6. And you'll notice the number of men is the same as 10 minus 6. This is frozen. My face is frozen. Oh, you get that lovely face. No, I'm just going to get rid of it by face. R equals 6. So now let's have a look. How many different patterns of men and women are there? Well, we could have had all 10 people together, but we don't care about the different women and men, just the fact that they are women and men. So we need to get rid of the number of rearrangements of the women and the number of rearrangements of the men, which is the same as 4 factorial or 10 takes 6 factorial. The only reason I've gone with this is because it's the same as this formula. And we're about to come up with something just for this formula. So I'd like to get used to using this when it's like either men or women, when it's a binary choice to make. And this totally comes out as 210. Let's have a look at question B. We've got space at the bus stop for 10 adults, and we're looking at men and women. How is this question? Okay, I'm going to go back to doing my boxes. First spot, second spot, third spot, fourth spot, fifth spot, sixth spot, 7th spot, 8th spot, 9th spot, 10th spot. And how many options do we have for the spot? First spot, we've got 2 because it's women or men. 2, 2, 2, 2, 2, 2, 2, 2. So that gives us 2 to the 10 ways that we could fill these positions. Okay. Sorry, I was expecting that to come out way differently. Using cases. This problem's really difficult because the word we've got is 7 letters long. So we need to figure out, there's a whole different bunch of ways of doing this. And we would like to figure out, so we're going to start off with all the ways if we've forgotten the P, and then all the ways if we've forgotten the R, and then all the ways if we'd forgotten one of the S's, it doesn't matter which one, and then all the ways if we'd forgotten the E. So forgot P. So this time we've got 6 letters left, but we've got 1 R, we've got 2 E's, and we've got 3 S's, which gives us 120. Wait. Yeah. Oh, no, that gives us 60. Sorry, I can't use my calculator. Forgot. This is going to be the exact same. 6 factorial times 2 factorial times 3 factorial, which is going to be 60. If we forgot an E, and this is just one of those E's, by the way, not both E's, forgot one E. 6 letters. We've got the P, the R, the E's. So we've got 1 of the E's left, and then we've got 3 of the S's left. And that gives us 120. If we forgot the S, 1 of the S's, then we've got our 6 factorial, all the letters. We've got the rearrangements of the P, the rearrangements of the R, the rearrangements of the E, and the rearrangements of the remaining S's. And that gives us 180. And that gives us a grand total of 240 plus 180, 420. 420. Thanks, that's it.